But basically, the Excel example we're going to look at has to do with unions and then wage differentials, okay? So if you go to Canvas under the in-class data folder, I had this union data. It's got one sheet that's blank and then one sheet that's got kind of hopefully what we'll recreate today, okay? So we'll start work on this blank file. And I've got a couple different kind of variables here. This is more of a business related example or an economics related example. I've got a bunch of different industries. So like architecture, arts and design, business and finance. I've got what the percent of those industries were belonging to a union in different years, okay? So one thing that we think about is the higher the percent of an industry that's unionized, the more power that union has, right? If every worker is a union worker, well, then the companies, in order to have any laborers, right, have to pay the union wage. If a small percent of the workers are unionized, well, instead of paying a union worker a higher wage, I'll just go and find out a non-unionized worker and pay them a lower wage. Right? So as unions get more power, as they have a higher percent of the total like workers within an industry, they can actually argue or they can kind of barter or bargain for higher and higher wages. So this other variable I have is I took union and non-union weekly earnings, and I found the difference between the two, right? So in 2008, in the accommodation industry, or companies that would meet that classification, the difference in union, non-union weekly earnings was $111, right? And then we can go through all these different, kinds of industries. So what we might be interested in, if I go over here, is I'm going to find the average kind of union membership. So just use that average to find that mean, go over to my union membership variable, Control Shift or Command Shift on a Mac, hold those two together and hit the down arrow, selects the entire column of data, hit enter. I got the average union membership is about 10.7%. And then the average wage differential across these industries is about $118, okay? So with this information, right, and this will be something like I would probably do for you ahead of time on the Excel assignment, but I'm going to kind of use those as a place to start and say, okay, my cutoffs that I'm going to use are 10 and 100, right? Just kind of make them nice, easy numbers to look at. Excuse me. So basically, I'll be interested in, is an industry have 10% or higher union workers in that year, or did it have below? Right? That's kind of like my A and A complement, okay? Or my B and B complement, however you want to think about this. And then the other kind of event I'm interested in is, do they have a wage differential between union and non-union workers of $100 or more, or the complement of that, which is just less than 100. Right? So I kind of had this table already typed out, so we didn't have to waste time watching me type and probably make a bunch of mistakes here. Right? But I've got my event A and A complement and my event B and B complement here. So I've been giving you contingency tables, but where do these probabilities actually come from? Well, if we had some existing data set with some historical data here, I could say based off of the data I have, I can count the number of industries across this time period that had 10% or higher union membership. So I'll kind of think of these as like highly unionized industries. And they also had wage differentials of $100 or more. Okay. Well, how can I count the number of industries in my data set that meet that criteria? Okay. I can actually use that Countifs formula, which you should have been using for that first Excel assignment. We kind of used it when we did that enrollments data. But the way we're going to use it today is a little bit different than when we were doing frequency distributions. So it still needs the same things. You have to tell it which variable to look at and then which criteria you want to be met in order to count that observation. So the very first thing we're going to do is, okay, I want you to go through this union membership variable. So I'm going to Control Shift, hit the down arrow, Command Shift on a Mac, scroll back up so I can show this to you so it's not small like it is up here in the formula bar. All right, so now you can see this. So it says, look through that variable that's in column C, which is that union membership, and count the observation only if it's greater than or equal to, and here it's kind of blocking out what my labels were here, but you can kind of remember it was 10% or higher union membership So I'm going to use an and sign here. And instead of putting in the number 10, I'm going to select on that cell that I had the cutoff in. And I'll show you how if you set it up this way, you could actually reproduce this table for any different cutoff that you were interested in. Okay. So go through the data, only count the observation if that industry was 10% or higher unionized. If you want to think about it that way. Almost sounds like euthanized, which is not good. So we've got this criteria has to be met in order for that observation to be counted. But then comma, we also only want to count it if that wage differential variable is greater than $100 or is $100 or more, right? This difference in earnings variable is 100 or more. So I could select this, click the first one, Command Shift or Control Shift, hit the down arrow. But since I can already see that it starts and stops, right, in 2 to 736, and I know that the variable I want is in this column H, so I'm not jumping all around and the screen's moving for you guys. I'm actually just going to type this in, right? H2 and then colon, which means go through H2 all the way up to H736. Right? I could have got that same cell reference in there if I, highlighted this entire variable, but I just typed it in. Okay. And then we only want to count the observation if it had 10% or higher, but also if this difference variable is greater than or equal to, and we had our cutoff for that up here set as 100. Okay. So go through this first variable, which is the union membership, count it if it's greater than or equal to 10, and then go through that wage differential variable and then only count it if that is also greater than or equal to 100. So this should give me the number of industries in my data set that had 10% or higher union membership and the wage differential was over $100 or more. Okay. Any questions on this? Those of you working along or? All right, so this is a little bit tricky here, but I basically want to do the same thing, but right, all these have different criteria, right? This would represent the number of industries with a less than $100 wage differential and below 10% union membership. Well, I still want to keep looking through the same variables and I'm still using the same cutoffs. So what I'm going to do here, and if I try to highlight all of this and hit my F4 or my Alt T, it won't work. And that's because there's equal signs and things in here. So I have to select these. I'm just going to freeze everything, right? So I'm going to select these, freeze those cell references, select this guy, freeze that cell reference, right? So now when I copy this, it should never change, right? So if I copy this over, I should get the exact same value. None of those cell references should have changed. If I copy this down, right, it should be those same cell references. Nothing should change, right? All I did was put dollar signs in front of all those references. Yeah.
How do you freeze on the Mac again?
Command T, I believe, is a shortcut. Now, another way you could have done this, so I'm going to undo my changes here real quick. Oops. If instead of freezing those and copying, if I highlight my formula, right click and hit copy, now I got to hit enter to get out of it. I can actually go here and let's just say it was blank. Right? And once I click on a different cell, if I then paste, right, into that cell, notice it didn't update any of my cell references. I can't drag it over, otherwise all those update, right? So I can do it this way, and it doesn't change any of my cell references, and everything works great. But if I would have just dragged it over, well, notice now I'm getting 0 because it's updating my cell references to these goofy columns and things that don't even have data in them. So 2 ways of doing the same thing. Oops. One was just to click on the cell so I can see the formula, highlight it, hit copy, go to the other cell, and then click paste, right? Right click and hit paste. Or I could have froze everything and then just dragged it over and down, right? That's probably the easiest way I would think to do it, especially since you would have had to copy and paste into 3 different cells here, but really doesn't matter, okay? Any questions over kind of anything I said there? it might be best just to freeze the cells just because it reinforces the idea that that's what makes it so that those cell references don't change, no matter how you copy it, right? Whether or not you drag it across, highlight it, copy and paste, if you've got those cell reference, kind of those dollar signs on the cell references, it'll never change. Okay? So I did that because I want the same setup, but in this category, I only want to count it if it has less than 10% and a wage differential of more than $100. So now when I'm looking at that unit membership variable, I don't want to count it if it's greater than or equal to. I only want to count it if it's less than 10%. Right? But I still want to be using that check for the difference in earnings of is it $100 or more, greater than or equal to 100. So all I did was go in there and change that one equality. And now it gives me the number of industries that fit these criteria. I then have to go in here. This one, it's going to be, is it 10% or higher? So that one I can leave the same. But is the wage differential less than $100? All right, so I'm just changing that equality sign to match up with the row or column heading or label, however you want to think about it. And then this last category, it will be below 10% and below $100. So these I will change to, is it less than 10%? And is it less than that cutoff of $100? Okay. So just went in, updated my equality signs so that they match up with my row and column heading. Okay. So now I've got, hopefully, right, I've counted every single observation. Okay. So just like the contingency table, once I have the top 4 left cells, well, if I add the number of industries that have 10% or higher union membership and had $100 or more wage differential to the industries with below 10%, but had a wage differential of $100 or more, that would just count up the total number of industries that have a wage differential of $100 or more. So I can add across the rows and down the columns, just like I did for that contingency table. So I'll, use that sum function just to add up those two numbers real quick. I could have just put equals this number plus the other number. It doesn't really matter. And then I'm going to drag this sum function down so that it adds up the next row. I'm then going to add down the columns using that sum function, right? Just adding up my two values here. I'm going to drag that across to add down this column as well. Right? So I'm just adding across the rows and down the columns using that sum function. So if I took every industry in this data set that had $100 or more wage differential, and I added that to the number of industries with a less than $100 wage differential, what should these two values add up to? That would just be every single industry in my data set, right? An industry either has a wage differential of $100 or more or a wage differential less than that, right? So it's counted one time in one of those groups. So if I add these up, right, these totals, I should get my total number of observations. What's one way I could check that real quick? Do you remember a function I said we can check to get the total number of observations is pretty quick? Yeah, just that count function. I then just highlight any of my variables. I'll just highlight this first variable, hit enter, and sure enough, I got the total number of observations there. If I don't have the total number of observations here in this contingency table, I made a mistake somewhere. I probably left an equality where I shouldn't have, or I forgot one where I shouldn't have, right? You can imagine if I was going through and changing these, and I don't know, let's say, I don't know if this one will change it, but okay, yeah. If I forgot the equality there, and not up, missing a few observations, I go back in. Oh, it was greater than or equal to that 10% here. Okay. Okay, now I've got every observation. Okay. Any questions up at that point? Yeah.
Can I just see your formulas for the
Up here?
Yeah.
Yep. Right, so we had those two variables selected. And then kind of our equalities line up with whatever the row and the column headings are. So those will be different for each one of those 4 cells. But then after those equalities or inequalities, we're just using these cutoff references that we had put up in what? Column O earlier. Any other questions? Yeah.
I have the same thing as you, but I got different numbers. I got 68 for the less than 100 and 10%. And I got 185 for the top right. and
So-
then
My guess would be, are you making sure if we have the equality here, it gives me 185? So there shouldn't be an equality on this one. All right, so we got to be careful with our equalities. Notice here it's 10% or higher. So here I should have greater than or equal to 10%. But on the other one, when it's below 10%, I should be using just a less than sign, not less than or equal to. I'm guessing that's what's causing the slight differences there. Yeah, and that's an easy thing to do. We have to make sure that our equalities, right? It's A and A complement, right? So that equality can only be on one of them. Any other questions? All right. So I've got all these frequencies now. Well, I wanted a contingency table, right? We were dealing with probabilities. So how the hell does this help me, right? Well, I mean, if I know that there's 221 industries that have 10% or higher union membership and a wage differential of $100 or more, and there's 735 total industries in my data set, if I chose one at random, what's the probability that they meet this criteria? Well, it would just be 221 out of 735. So when we have frequencies set up for these different combinations of event A and B and their complements, to turn these frequencies into probabilities, all we have to do is take the number of industries that fit that criteria and divide it by my total number of observations, right? So that's kind of anytime we have probabilities, and once we get into this idea of Bayes' theorem, which is the next topic after we get done with Excel here, anytime we see a probability, there's really a frequency floating around in the background. That probability just represents some frequency divided by the total number of observations, okay? So I basically want to go through and do that for every single one of these cells up here. And I'll kind of show you, on the Excel assignment, usually what I do is if I give you the labels, right? I kind of had this table up here. Let's say it even when it was blank. If I copy it and then come down here and paste it, oops, and then just delete everything. Well, now I don't have to retype all my labels, right? They kind of match up with whatever table I had before was. So I think in the assignment, I'll give you a Word document and it kind of has the table in the Word document. You can copy and paste that right into Excel so that you just have all the labels and the boxes set up correctly. Saves you a little bit of time. Now, if you try to copy and paste it from the web browser, was it someone in this class who stopped by my office and we couldn't figure out why it wouldn't copy and paste? I'm looking to see if I remember. No, they're not in this class. But if you just try to copy it from the web browser and paste into Excel, it like treats it like a text delimited file and it just puts it all into one cell and it just looks like gibberish. You have to download the Word document and then from Microsoft Word, you can then copy and paste it over into Excel and it'll get these labels in there for you pretty nice so that you don't have to type them all in. But regardless, what we wanted was that frequency divided by my total number of observations, right? So I want to do this for every single one of these frequencies, but what do I have to do before I do that? Before I start copying this over and down? Yeah, I want to divide each one of them by the total number of observations. So I never want that cell reference to change. As I copy this over, I want the frequency to update from K9 to L9 and then to M9, right? But I never want that total number of observations to change. So I'll put $signs around that, okay? Now I should be pretty set. And if I forget to, I'll be reminded pretty quickly because I'm going to start getting values in this, these error messages. So I go back, oh yeah, I need to freeze this, right? Because if I don't freeze that, then when I get down to here, it's using blank values, right? So now when I copy this over and down, okay, now things are starting to look okay, right? And this cell down here, once I get to my contingency table, Well, this should always be the total number of observations over the total number of observations. So this should always be 1, kind of representing the entire experimental outcome space, right? And then here's the probability of event A, here's the probability of A complement, probability of B, B complement, and then the 4 intersections that match up with whatever row and column headings we have, okay? Any questions over this? I think since I'm behind this thing, I can have my mask down. So I'm going to stay like this for a little bit because I feel like I sound probably a little bit easier to hear and I can breathe. So, all right. So are we okay up to this point? Okay. So, you know, these look a little bit messier than the tables that we were looking at on the slides, right? But we can still use them to find some pretty interesting things. So I had a couple things that I set out ahead of time. And I might come up with a couple, you know, just off the top of my head here. But let's say I wanted a probability that if I selected one of these industries at random, that their union membership is 10% or higher. All I have to do here is put an equal sign. I don't even have to type in the probability. I know that that's just 10% or higher. It's that 0.39 right there. All right. Hit enter. What's the probability it's 10% or higher and the difference in wages is $100 or more? Once again, well, that's just, is it 10% or higher? And then those top 4 left cells represent the intersections or this and this. So 10% or higher and $100 or more wage differential. It's just that 0.300. Right? What if I wanted, what's the probability that I see $100 or more wage differential given it's 10% or above? Well, if I want a conditional probability, we said I can rewrite that as the intersection of the 2 events divided by what I'm conditioning on. So if I want the intersection of these 2 events, I just want $100 or more wage differential and 10% or higher. But then I'm going to divide that by, well, what am I conditioning on here? I'm conditioning on the fact, whatever's on the right-hand side of that line, I'm telling you, well, given that you know the industry has 10% or higher union membership, so we'll divide by the probability of that. So the probability of having 10% or higher union membership, you just go down to that total. Okay? And the idea behind this is, once you tell me to condition on this, and I'll actually, let me get out of here real quick so I can make this a little wider so we can have this on one line. Once you tell me that I know I'm looking at an industry that has 10% or higher union membership, if I look at that, well, I know then I'm in one of these categories. So of those 39%, or right, the probability of 0.39, that when I selected an industry at random, it had 10% or higher union membership. Of those industries, only 0.09 had a wage differential less than 100, and 0.3 represented the ones that had $100 or more. So I know that if you tell me that the industry has 10% or higher union membership, it's more likely the wage differential is $100 or more than being less than 100, right? You can kind of see that once I condition, I'm like only looking at that column, right, of my contingency table. Okay? I could then do the same thing, but condition on the other thing. So given that it's below 10% unionized, now what's the probability that it's $100 or more wage differential? Well, once again, it's the intersection of these two. So $100 or more, but below 10%. But now I'm going to divide by what I'm conditioning on, which is having below 10% union membership, which will just be down here in the total. And I can kind of see here, so about 60% of the industries have union membership below 10%. Of that, you know, kind of 0.6, 0.25 has these really high wage differentials, 0.35 has lower wage differentials. So not as much of a mismatch as kind of when I was looking over here at the industries that had 10% or higher. But I can find both of these conditional probabilities. So what is this telling me? This is telling me that given that I know that there's a low percent of unionized workers in an industry, the probability that the union can get their wages to be $100 higher than non-union workers is only about 0.4. However, if they're in an industry that has high union membership, right, given that I know that they've got 10% or higher, the probability they get $100 or more wage differential rises up to 0.76 as opposed to 0.4, right? So, having a higher percent of your industry unionized, if you're a unionized worker, it's more likely you can expect to be making $100 more than your non-union counterpart, right? Almost doubles the probability, right? 0.4 to 0.76, 77, right? So this kind of tells us the relationship between, unionized, more unionized industries, and then that wage differential. But there's a pretty strong, there's going to be some type of dependency there, right? And I could check the law, okay, here I have my conditional probability. I know they're independent events if this is the same thing as the unconditional probability of making $100 or more. So that, if I think about, is up here, 0.55. Well, that's not the same thing as 0.44. So these would be dependent events or not independent events, okay? Any questions over or kind of how we use it? I mean, this part really doesn't have to be done in Excel. I could do this by hand, but as long as I have the values in Excel, why type these out? Why try to round them to the 4th or 5th decimal? I'm just clicking on the cells here, right? Just clicking on the cells to get those numbers. It makes it a lot easier, okay? And I can be a lot more precise. Any questions over anything there? What if I tried this, or what if this was a little bit different? Okay with that? Okay. Anything else? Oh, I want to show you a couple things here. So notice when I was using that Countifs, like for your assignment, technically, you didn't have to use cell references here. You could have typed in the 10, you could have typed in the 100. Doesn't change anything. I'm going to undo those results though. But if I use cell references, right, then if later on I want to change things, and maybe I don't put 10 and 100 here in my labels, I just put high union membership and low union membership, and then I want to play around with the cutoff value. Well, maybe I want to define high union membership as 15% or higher, right? Updates my frequencies, updates my probabilities, updates my conditional probabilities and things that I found down here.